We want to obtain the sum of n terms of an arithmetic progression. So let's say we have some numbers a1, a2. So a1 will be the first term, a2 is the second term, a3 is the third term, and this continues all the way up to nth term. So an will become our last term or the nth term. So let's say this particular arithmetic sequence is in AP. So this means it's an arithmetic progression, which would mean that we have a common difference. Now we want to find out the sum of each of the terms. If we add each of the terms, what will be the sum up to the nth term? Meaning we want to find out if we add the first term to the second term and then the third term and add all the terms up to the last term, we need to find out what is going to be its value. So let's do that. So what we'll do, we'll begin by first considering that, say, the sum is given by a1, a2, a3 all the way up to the nth term. Now what we'll do, let's label this as number 1. Now we'll take the same sum. We are going to take the same sum, but instead of starting with the first term a1, we're going to start from the last term. So we'll consider the last term an as the first term. Then we'll consider the second last term and treat it as the second term. Second last term going to be an minus 1. Then our third term will be an minus 2, and this goes on to the last term. Now the last term will be denoted by a1. Now what we'll do, we will add the two sums. We're going to add 1 with 2. So that means we have s plus s on the left hand side. So this will be equals to 2s. And on the right hand side, we are going to add each of the terms term by term. That means we'll add a1 with an. Then we are going to add a2 with an minus 1 plus a3 with an minus 2 all the way up to plus an plus a1. Right. Since we are interested in finding out the sum, so that means here we have 2s on the left hand side. We're going to divide both sides with 2. So we're going to get half whole multiplied. Now we're going to use a theorem. The theorem states that if we have an arithmetic sequence a1, a2, and it goes all the way up to an, if we consider any term, from the beginning and add it to the equivalent term from the end, meaning let's say we are considering the kth term from the beginning, and add this to the kth term from the end. So the sum is always going to be equals to the sum of the first term and the last term. This is always going to be true, meaning that if the terms equidistant from the first term as well as the last term, when we add them, this is going to give us the first term plus the last term. In other words, if we add the second term with the second last term, that this is going to be equivalent to the first term plus the last term. Similarly, if we take the third term from the beginning and add it to the third term from the end, so the sum is also going to be equals to the sum of the first term and the last term. So this is a theorem. So this is what we're going to apply here. So here we already have the first term added to the last term. So in the second term here we have this a2 added to an minus 1. So a2 represents the second term from the beginning, whereas an minus 1 represents the second term from the end. And this sum is always going to be equals to the first term. So that means this will become equivalent to the first term added to the nth term. Similarly, the third term is also going to be equivalent to the first term added to the nth term. So here we will observe that all the terms are similar to a1 plus an. That means the first terms to last term, meaning we can say that our sum is actually equals to half multiplied to, so we have a1 plus an, so this is the first term added to the last term, and this is repeating n number of times. So we're also simply going to multiply with the number n. So here s will be given by n over 2 multiplied to the first term added to the last term. So this is the formula for finding out the sum from the nth term. In other words, we can also say that the sum to the nth term, this will be simply equals to, take the number of terms divided by 2 and multiply this to the first term and add it to the last term. So this is how we can obtain the sum up to the nth term of a given arithmetic progression. So there is another way. So there is another formula. Let's also try that out as well. So let's say we have the same sequence of number a1. So we are going to consider s as the sum of a1 plus a2 plus a3, and this goes all the way up to the nth term. Now we know that what's the formula for finding out the nth term. The nth term is given by the first term. This is our first term. We are represented by the letter a in lowercase, plus n minus 1 times the common difference d. So this is going to be a common difference. Now that means we can represent a2. So our a2 will then be represented as a plus, so we have 2 minus 1 times d, which is simply equals to a plus d. And if we consider our third term, that's going to be equals to a plus 2d, and so on. So that means we can rewrite our given sum. So sum can be expressed as our first term. a1 is simply the first term, so I'm representing a1 as a plus a2. So a2 will then become a plus d. Then we have a3, which is going to be a plus 2d. Then this continues all the way up to the last term, which is a plus n minus 1 times d. Right. So let this be number 1. Now we are going to do is we'll take the sum, but this time we are going to reverse the terms. Means we'll consider the last term, consider in equation number 1 as the first term. So here we have a plus n minus 1 times d. This is going to be a first term, followed by a plus n minus 1 minus 1. So this is going to be the term which is previous to an. So this is d. So this continues all the way up to the last term, which is going to be simply a. So let's consider this as equation number 2. Now that we have equation number 1 and 2, we're going to add equation number 1 to equation number 2, such that we get 2 times s equals to. So here we are going to add this first term to this first term. That means we are going to add the corresponding terms. So we get 2a plus n minus 1 times d. So this is going to be our first term. Plus now we're going to add this particular term and the second term to this corresponding second term of equation number 2. So here we also have 2a plus n minus 1 times d. Right. Similarly, we'll see that our third term is also going to be equals to 2a plus n minus 1 times d, and this will continue all the way up to the last term. So when we add the two terms to last term, so this will give us 2a plus n minus 1 times d. So here we can say that this expression or this term 2a plus n minus 1 times d, 2a plus n minus 1 plus d, so this is getting added to itself n number of times. So here we can say that we have simply n multiplied to 2a plus n minus 1 times d. Since we need only the sum s, so our s will be equals to n over 2 multiplied to 2a plus n minus 1 times the common difference d. So this is going to be the sum up to the n terms of our arithmetic progression. So we have obtained two formula. So one formula is given by Sn equals to n over 2 multiplied to the first term added to the last term or the nth term, or we can also have Sn equals to n over 2 multiplied to 2a plus n minus 1 times d. So actually these are exactly the same formula, because we know that our nth term, so if we use the formula for the nth term, which is a plus n minus 1 times d, and we replace it this place of an, this will get added, the first term will get added to a to give us exactly this particular formula. So let's use this formula to work on some problems. So here we need to obtain the sum of the first 20 terms of the arithmetic progression given by 1, 4, 7, 10. So we will need the first term. So here from our given sequence or from the given arithmetic progression, our first term a is, then since it's already given that it's an AP, that means we'll also have a common difference. So common difference can be obtained by subtracting 1 from 4. That means from the first term from the second term, and this is going to give us a value 3. Now our task is to obtain the sum up to the 20th term. Let me use both the formulas to obtain the sum. So first we are going to use the formula that we have n over 2 multiplied to 2a plus n minus 1 times d. So here n value is going to be 20. So we have 20 over 2 multiplied to 2 times the first term, which is 1, plus n will be 20. So we have 20 minus 1 multiplied to the common difference, that is 3. So we have 20 divided by 2, so that's going to be 10. So we have 2 plus 19 times 3. So 19 times 3 will be 57. So we have 10 multiplied to 59, which is equals to 590. So this particular formula is telling us that the sum of the 20 terms, sum of the first 20 terms of this given arithmetic progression is going to have a value of 590. Now, we can also find out the last term. So the last term is actually going to be the an, which is the 20th term. So our 20th term is actually a plus n minus 1. That means 20 minus 1 times the common difference d. So our first term is 1 plus 19 times the common difference, which is 3. So here we have 1 plus, so 19 times 37, that's 57, which is going to give us the value 58. Now we have the last term. So our sum up to the 20th term, that simply equals to n over 2 multiplied to the first term and the last term. So our last term is 20. So you have 20 over 2 multiplied to the first term, which is 1, plus the last term, which is 58. So we get 10 multiplied to 58 plus 1, so that's 59. So this is also giving us the same value, which is 590. So we can either use this particular formula or this formula. Either of them is going to give us the same value. Let's do another problem. So here we need to obtain the sum. In this particular problem, we can quickly obtain few of the values. Here the first term a will be 5. The common difference d will be 13 minus 5, which is equals to 8. Then we also have our last term an, which is equals to 181. Here, from using these three information, we can find out n value. We know that the nth term is given by a plus n minus 1 times the common difference d. So substituting all the values, so we have 181 equals to 5 plus n minus 1 times the common difference d, which is 8. We have 181 minus 5, so that's going to be 176, which will be equals to n minus 1 times 8, or simply n minus 1 equals to 176 divided by 8. Now 176 divided by 8, that's going to be, and we have 8 times 2 is 16, so it's going to be 22. So n value is going to be equals to 23. Now that we have the value of n, so we know that in this particular series has got 23 terms. So all we have to find out is S23, the sum up to the 23 terms. So this will be equals to 23 divided by 2, all multiplied to the first term plus the last term, which is 181. So we have 23 over 2. Multiply to 181 plus 5, that's going to be 186, which is 23 multiplied to 186 divided by 2 is going to be 93. So this is going to give us a value 22,139. So this is going to be the sum of the 23 terms, or you can simply do the sum of the given arithmetic progression. So here we need to obtain the sum of all the 3-digit natural numbers that are divisible by 7. That means we'll first have to specify the given arithmetic sequence here. What's the smallest 3-digit number that's divisible by 7? So that value is going to be 105. Now since they're divisible by 7, it's quite evident that the common difference is actually going to be 7. So if we add 7 to 105, we're going to get the next digit that's divisible by 7. So that's going to be 112. Similarly, we add 7 to 112, we're going to get 119. This goes all the way up to the last digit. The last 3-digit number, or the highest 3-digit number that's divisible by 7 is going to be 994. Fine. Now our task is to find the sum of all these terms. Our goal will be to find out as n equals to 105 added to 112 plus 119 all the way up to the last term, which is 994. So if we use the formula, it's simply going to be n over 2 multiplied to 105 plus 994. So this is going to give us the value 9 over 2 times. So here we have 1099. So that means we'll need to find out the value of n here, which is the number of terms. Now we know that this particular sequence is in AP, or in arithmetic progression, which means that our first term is going to be 105, our last term is going to be 994, and then our common difference, that's 7. Using these three values, we can now find out the value of n. We know that an is given by a plus n minus 1 times the common difference d. Let's plug in the value. We have 994 equals to 105 plus n minus 1 times the common difference 7. So 994 minus 105, that's going to give us the value 889, which is equals to n minus 1 times 7. Or we can have n minus 1 equals to 889 divided by 7. N minus 1, this is going to give us a value 127. This means that our n value is going to be 128. So which means that there are 128 such numbers, 3-digit numbers, which are divisible by 7. Now we'll come back to s on n, which is actually 128. So we have 128 divided by 2 multiplied 2099. So we'll use a calculator, and this is going to give us a value 70,336. So this is going to be the sum of all the 3-digit numbers that are divisible by 7. So here we have to obtain the sum of all natural numbers exactly divisible by 3, and these numbers are going to lie between 250 and 1000. So let's begin. So first, so we know that any number is divisible by 3 if the sum of the digits is also divisible by 3. So if we add the lowest number, which is 250, 2 plus 5 plus 0, so this is going to give us the value 7. So we know the 7 is not divisible by 3, but the number next to 7, which is divisible by 3, is 9. So that means if we add 2 to our digits, then we'll get 252, and the sum of the digits is going to be 9, and this number is going to be divisible by 3 because 9 is divisible by 3. That means we'll have to start with our smallest number, 252. To find out the next number, all we have to do is add 3 to it. So this is going to give us the value 255. So this number is also going to be divisible by 3. Clearly it means that we have a common difference of 3. So 255 plus 3, this is going to be 258. Next, what we have to do is find out the number which is less than 1000 but divisible by 3. So we know that 1000 is not going to be divisible by 3, but if we take 999, the 999, this is divisible by 3. So that we know that the last digit is going to be, the last term of this particular arithmetic progression is going to be 999. So let's try to find out the number of terms that are present here. So here we have our first term, which is given by 252. The common difference is 3, and our last term or the nth term is 999. So we're going to use the formula for the nth term. So we have 999 equals to 252 plus n minus 1 times the common difference d. So we have 999 minus 252 equals to n minus 1 times 3. So 999 minus 252, that's 747 equals to n minus 1 times 3. So n minus 1, this is going to be equals to 747 divided by 3, which gives us a value n equals to 250. So this means that there are 250 numbers between 250 and 1000, and these numbers are going to be divisible by the number 3. So our task will be to find out the sum of all the digits. So that means sum up to the 250 terms, and this is simply going to be equals to 250 divided by 2, and this entire thing is multiplied to the first term added to the last term. So that means 250 divided by 2, that's 125, multiplied to 252. So this is 1250 times 1, and when we take the product with 125, we're going to get 156,375. So this is going to be the sum of the 250 terms, and each of the terms are divisible by the number 3. Let's move on to the next and the final problem. Now in this problem, we have to obtain the sum of all odd natural numbers that's lying between 2 and the number 100, and also it has to follow the criterion that each of these odd numbers must be divisible by the number 3. So let's begin. First, we will try to find out the numbers that lies between 2 and 100. So the first odd number, which is greater than 2, is going to be 3. Now 3 is divisible by the number 3, so we are fine with it. Next, the next number in the sequence which must be an odd number, and also it has to be divisible by 3. So we cannot take the number 6 here because 6 is the next number after 3. What we have to do is actually consider the multiples of 6. We know that the multiples of 6 are 3, 6, 9, 12, 15, and then 18, 21, and it goes all the way up to the number which is less than 100 is going to be 99. Now we only have to consider the numbers that are odd. So that means we'll have to consider here 3, 9, 15, 21, 99. So that means this is going to be our actual sequence. We have 3, 9, 15, 21, and this goes all the way up to 99. Now our task is to find out the total number of terms present in this given sequence. This is in AP, this is an arithmetic progression. So our first term is going to be 3. Then our common difference, this is going to be 9 minus 3, which is equals to 6. Then we have our last term, the nth term, which is 99. Now let's find out the total number of terms present here. So we have 99 equals to a plus n minus 1 times 6. The 99 minus 3, that's 96, which will be equals to n minus 1 times 6, or n minus 1 equals to 96 divided by 6. So this is going to be 13. Oh, no, 16. 16 times 6 is 96. The n value is equals to 17. So that means there are 17 such terms, which are 17 terms lying between the number 2 and 100, which are odd as well as divisible by 3. So let's try to find out the sum of this sequence. So what we are trying to find out, that S17 equals to 3 plus 9 plus 15 plus all the way up to 99. So we are trying to find this particular sum. S17 will be equals to 17 over 2 multiplied to 3 plus 99, which will be 17 over 2 multiplied to, so 99, 102, which is simply 51. So 51 times 17, that's 867. So this is going to be our sum.